Good evening, all of you, and very happy to see our alumni, Subhash, Sheelapriya from United States of America, and Sakthivel from France, all from ECE department. Very happy for them to see them all placed in core companies in nice positions as well. I would like to welcome all the participants. Actually, we had around 100 registrations. Maybe slowly they'll be joining. I would like the panelists, that is our alumni, to share their experiences, their ideas, so that it is going to be useful for our students. We have many student participation as well as faculty participation here. So on behalf of ECE department and KCG College of Technology, myself Kavita Balamurugan, HOD ECE, would like to welcome everybody for this session on career experiences. And it's a warm welcome for everybody this Saturday evening, and very happy to see you all. Now we have as moderator Jonadab from 8th semester ECE for this session. So over to Jonadab now. I'll just switch off my video now, okay, so that bandwidth is not getting affected. Okay, so Jonadab, you can continue.
Good evening to my fellow peers who are watching it live, and good evening to the staff also watching. So basically, so this is going to be a panel discussion. That means there's going to be a healthy discussion between the panelists and the students. So the first half an hour will be the panelists giving their own presentations. The second half of the half an hour will be basically me asking questions basically that I got from other students, and the last one will be Q&A from the students itself. So without further ado, I request the panel members to start with their presentations. If both either Mr. Sakthivel or Mr. Subhash or Ms. Sheila can start with no particular order. You can anyone can start.
Shakti, do you want to go ahead and start?
No, I think you guys can start, and then I'll do my introduction, and then I'll just continue with the first.
Just before that, the participants, please put your questions in Q&A box. Please don't do that in chat box. Whatever questions you post will be there in Q&A that will be answered at the end of the session. Yeah. This is for participants. Now you can continue, Subhash, and you can share your.
All right. Can you see my screen?
No, Subhash.
Yeah, not yet.
Is it loading or?
No, I'm not able to see it loading also.
Okay. Okay.
Yeah.
We can see that, sir.
All right. So we'll just briefly introduce ourselves, and we can get the meeting started. So I'll briefly introduce about myself. So I went to KCG College of Technology to do my undergraduate studies. I was an ECE student. So I was part of the batch from 2009 to 2013. So it was around, I think, 2000, when I was in my 4th semester, that a lot of my friends were giving their GRE exams and planning to go abroad to do their masters. So that's when I kind of said to myself, okay, I'll try to pursue that path. And I gave my GRE, I think it was during my 4th semester. So it was a little early, compared to a lot of others. So after that, I started trying to build my profile, to apply to universities here. The way that I did that was me and a few of my friends, we presented papers in conferences. So that was a way that that it helped me build my profile, so I could mention it in my statement of purpose when I applied to the universities. So after that, I actually started applying to universities in my 7th semester. So typically the deadlines to apply would be, around the end of December. So I think I applied in October, way before the deadline. And then I think I started getting admits from universities in March 2013. And then I had to schedule my visa interview and stuff, and then get those formalities out of the way. And then I came to the US in 2013, August 2013, to do my master's. I did my master's in electrical engineering in Arizona State University. I can share my experience there a little bit. It was such a learning experience there. So, one of the very important things that I learned there was, how to manage my time. So studying here in the US, we had to, take care of our living expenses. So I worked part-time on campus. So that was about 20 hours a week. And then, and then the rest of the time is for doing your coursework. Typically we would take 3 courses every semester, and then that would be, so we would have, the classes would be just 1.5 hours. So two classes per week per course. There'll be 2 classes, 1.5 hours. It may seem like very little time, but apart from that, there would be a lot of projects that they would assign. Assignments would be there. We would just spend a hell lot of time in the labs, trying to complete our assignments and projects. So time management was a very important aspect that I learned during my time at Arizona State University. And then so towards I think it was around early 2015 in January, I started applying to companies for full-time opportunities. And then I finally landed a job as an Asic design engineer in Delphi Technologies. So I started there in June 2015, and I've been working there as an Asic design engineer for the last 5 years, around 5 years. So Delphi Technologies, so we are basically a propulsion. So we provide propulsion technology solutions to automotive companies. So as part of that strategy, ASICs are a very important aspect of that. So we develop and design ASICs that go on, engine control modules, transmission control modules, electric motor controls, and stuff like that. So so that's a brief introduction about myself. I'll turn it over to Sheila.
Hi everyone, I'm Sheelapriya. So even I joined KCG college in 2009, and I did my undergrad there in ECE. So after graduating from undergrad, I joined Amazon as a quality analyst. So this job was basically not much of a technical job initially. So it was more on pricing analysis for the products that go live on the website. And then later on, I had the opportunity to move inside Amazon as a product quality analyst. So that was a bit of technical stuff. And in Amazon, I would say it was an amazing experience for me, mainly it's about like communicating. I had an opportunity to communicate with different people all over the world. So I learned a lot on that. And apart from that, I learned a lot about teamwork, how important a teamwork is to deliver the project. And yeah, that's it about Amazon. And after 3 years, I got married and I moved to US. So after moving to US, that's when I decided to pursue my master's in computer engineering. So after moving to US, I wrote my GRE and my TOEFL. So I prepared both GRE and TOEFL on my own. I never went to any classes. So there are a lot of materials that are available online, and there are a lot of even textbooks and tutorials that are available. So I just prepared using that, and then I applied and I got admit from Purdue School of Engineering. So there I did my major in computer engineering. So computer engineering is more about embedded systems, and my experience there was like what I learned there was like much more on practical knowledge. There are like, for every course I take, there will be 1 or 2 projects. So we typically work on practical things. And apart from that, we have the option to choose what course we want. And so you can choose based on on your interest, and yeah, and what is really important. That's like how you decide. And then so in 2019, so like during the career fair, I got an opportunity for internship. So in the summer 2019, I did an internship with Aptiv, so as an embedded systems engineering in a systems engineer. So Aptiv is basically an automotive company that gives solutions for autonomous cars, and it gives solution for mobility and connected systems. So Aptiv has branches all over the world, and there's a branch even in India, in Bangalore. There are a lot of people who work from there. And so I would like to share my internship experience. So in US, there are a lot of, most of the companies, they give a lot of importance for internship program. That's because they hire the students while they're doing, let it be undergrad or graduate or in like masters. And during the summer, mostly they take the students and they start training them for the real how the industry world is. So they give them small projects. So when you're studying and you're doing such projects in industry, you get to learn more and understand more, and they're constantly assessing you how you're performing and understanding. And at the end of the year, like when you graduate, you have a lot of opportunity for them to call you back for your full-time offer, like full-time job. So while I did my internship, I saw many people, they have started their internships right after their schools and even first year. So they had like more knowledge like on handling tools, especially because that is very important to work in the industry. And so here I had mostly they would assign a mentor. So that mentor would have a huge number of years experience. So my mentor had around like 30 years of experience, and he had deep knowledge on the product which I was supposed to work. And he used to answer every question in detail and explain to me. That made me more interested towards the subject, and made me understand much better. And apart from that, the best part of the internship programs here is that they let you, that the company, they'll organize a lot of networking program with other team managers, so that you could get to connect with other team managers and show like what your interest is and all those things. And you would get like they would even give a brief note on what they're doing in other projects and tools. So that is actually very helpful to understand how things are working in real world. And I got all these opportunities. And end of the internship, you here mostly you have to give a final presentation. So the presentation is like what you had did from the beginning of the internship, and what like your complete project, what you have worked on. So in that, you would call other team managers and the HR, everybody would come, and they would look like how you have did that and what you have did that. So they already have an idea and assessed you where you belong and where you fit. So this really helps you to land a job, full-time job in the same company. So mostly they would take back. And so the same thing happened for me. So after being a systems engineer, I got an opportunity like to for a full-time offer for embedded software engineer. Of course, I did have to clear the interviews for that role because that is not same as the systems engineer. But yeah, I had to clear that, and I got the job. And I started working like from this year January as embedded software engineer. So I basically now I write software code for radars that would detect the objects and give the response back to the electronic system in the car. Yeah, that's it from my side, I think.
All right.
I think Mr. Sakthivel from.
Yeah.
Yeah. Okay.
Yeah, hello, everyone. My name is Sakthivel, and I also graduated from KCG in the year 2013. And yeah, at the time, I was not interested in doing masters or any higher studies. I was like, okay, enough of studying. Let's go and work in some core companies. That was my only motive. So I attended walk-in interviews in some core companies, and fortunately, I got a hardware engineer job in data patterns. It's a company in Navalur. I think some of you would have known it, and they make electronic systems for military and space applications. So there I worked for around 2.5 years, and
Excuse
that
me,
was.
Sakthivel, little more louder.
Yes, ma'am.
Little more louder, please, Shakti.
Okay, ma'am. Let me
Okay.
increase the
Okay.
mic volume. Just give me a second. Is it okay now?
Yeah,
Yeah,
fine.
yeah,
It's
much
very
better.
good.
Yeah, thank you.
Okay. So yeah, there I got a good opportunity to learn a lot of stuffs. For example, they made amazing radar systems for military applications. So I was in a project where I get to work on designing communication modules for satellite systems and also for ground station receivers. So with there I learned a lot about the communication system, the communication theory, and RF technologies. So that was a good a good awareness to me to get to know the industrial the industrial opportunities available in that field. So yeah, after that, after the end of 2 years, I was happy with my job, but still I wanted to learn more because the learning opportunity was plateauing there. I couldn't explore much beyond the scope of my work. So I thought of doing master's degree. So I started preparing for GATE exams initially, and that plan didn't work out. And then I started applying for because I wanted to do MS or MTech in IITs. And then I parallelly applied for universities in Germany also. And fortunately, I got an admit from TU Darmstadt. And then in 2016, I quit my job in HCL Technologies and went to pursue my master's in information communication engineering. So there my experience was I mean the learning experience compared to my bachelor's, it was phenomenal. The the way of teaching and the way they use the technology for teaching, it was entirely different. And also they have these kind of project seminars, which was really helpful in if you're interested in research oriented career. So yeah, that helped me really to find an internship and also do my master thesis at Intel. So yeah, at the end of my master's program, I did my master thesis at Intel. So my master thesis was on LTPC decoders. So that was one of the amazing experience in my life. It was also a good learning experience. So yeah. So after that, I started applying for jobs in different countries across Europe, and then I found this research institute in France, Eurecom. So they work on 5G RAN development, and also they had previously worked on LTE RAN developments, and now they are working on 5G RAN developments, and also they are specializing in data science also. So here my part is basically developing physical and MAC layer procedures for 5G protocols. So yeah, that's it about my introduction. So I think we have a couple of slides ahead. So I will continue with that. Yeah. So we'll talk a little about the different job opportunities available in the core industry. So here we took mobile phone as an example to talk about the different jobs you can find in this field. So this is a generic block diagram of a mobile phone. So there is wireless modem, CPU, interface modules, GPU, etc. So the system design so the system design begins first. So they get the requirements. Yes,
1 minute, Shakti. Sorry to intervene in between.
Yes,
we have few people putting in the chat telling that they are not able to hear properly. Can you slightly improve on your audio?
Okay. Can you tell me what I mean what problem exactly you're facing? Is it the volume itself, or is there some distortion?
No, volume is perfectly like okay. There's no distortion and all, but it's like feeble.
Okay, the volume is low.
Low, yeah.
Yes, yeah. Okay. It's like it's just a little more louder into the mic. I think that's what people are not hearing properly. That's it, sir.
Okay, actually, I'm holding my mic literally. Okay, let me grab another microphone. Just a second.
Okay, yeah, sure. We'll wait. Yeah, and to the rest of the students who are watching, so you can still post your questions in the Q&A. So that means at the end of this presentation, we'll answer it. So rather than waiting till the end to post your questions, you can post your questions now itself at the Q&A bar. Okay, so that we can answer it later.
Hello, can you hear me?
Yes.
Sir, yes, sir. We can hear you properly.
Yeah, okay. So yeah, so the system design team of a particular phone gets the requirements, and then the requirements like number of SIM cards and what are the other features, etc. And then they start to work on the motherboard, which is a primary component. So the motherboard has these different modules. So the team first designs schematics to first they choose the components. So the components such as ICs, the CPUs, GPUs, the wireless modems, etc. And then they design schematics to do the logical connections. And then once the schematic is done, they move on to the PCB layout. So here, this is generic job role for this kind of design team, and there are a lot of companies in and around Chennai and even Bangalore which do this kind of jobs. For example, any simple electronic product, and then that involves this kind of component selection, schematic design, and then PCB layouts. So the primary important subject knowledge for these kind of jobs would be circuit theory, analog and digital circuits. And also good to have skill is the tool skill, like schematic design tools. There are a lot of design tools available, and also for PCB layout, there are PCB CAD tools to do the layouts. So if you want, or if you're interested in this kind of jobs, then it's very important to have these subject knowledge and also the tool knowledge before you even apply for such jobs. And yeah, next thing. So yeah, this is a yeah, okay.
Sorry about that.
Yeah, this is just depicting how the schematic design looks like, and then once the schematic is done, they move on to designing the PCB, and then the final PCB would look like this. So we talked about the system design aspects, and now so now we talk about the individual modules. So here we will look at how the how the wireless modems are developed. So the requirements are generally given or formed by 3GPP or IEEE standards. The LTE and 5G standards are governed by 3GPP, and Wi-Fi, Bluetooth are governed by IEEE. So big companies like Nokia, Qualcomm, they're all part of 3GPP. So they are the ones who define the standards. And then once the standard is finalized, each company start to build their products based on the standards. So the first step is the research and development, so that they do a lot of researches to meet the requirements. For example, if the 5G technology demands so and so data rates, and that should be properly met. So to do that, a lot of research has to be done on that. So if you are interested in those kind of jobs or career, then you should be strong with communication theory, DSP, and also math is a very important subject. Random processes are very crucial, and also MS or PhD is required to get into this kind of jobs. So if you want to work on research and developments, then definitely you have to do MS or MS by research. And also PhD also is an option if you are interested in academia or even more industry-based research works. For example, people who hold PhD degrees are the ones who will be governing the 3GPP standards. And also, you will also have an option to work as a professor or postdoc in universities or research centers. So yeah, that's it from my side. And then once this algorithm is developed, so from the requirements of 3GPP, the research and development team build the algorithms to meet the requirements, and then these algorithms should be ported to hardware or ASIC. So we give the design to the ASIC team, and then the ASIC team develop the hardware from them. So Subhash will talk about the ASIC development lifecycle.
All right. So I'll just briefly talk about the ASIC design flow. So Shakti, he just described the requirements at a higher level, at the system level. So as he said, the R&D would go into how to meet the requirements for the different IEEE standards or other standards, and then once they develop algorithms, it needs to be ported to hardware, and that's when the IC design team would come into play. So this flowchart just basically describes what the design cycle for ASICs would be. So you'd get a design specification from the IC architects. So they would work with system teams and then define what needs to go into the IC at a very low level, and then they would do some behavioral modeling of whatever they put in the spec, and then they give it to us as IC designers. And then the first thing that we would start doing is do the RTL design for each block. So what goes into RTL design is it's basically we use Verilog and System Verilog to design whatever specification they've provided us. So we use Verilog, System Verilog to describe it at a very abstract level. And then once we do the RTL design, we run simulations to test that the RTL code is working as per the specification that's been provided. So there would be a lot of back and forth activity here, because so once we do the RTL coding, we might find bugs, issues. We need to run simulations. If we find issues, we go back to RTL coding. We fix those issues, rerun the simulations, and once we've determined that okay, things are working the way we expected to, then we go ahead and do logic synthesis. So this is the next level. So RTL is a very high level description language, and then from there we need to convert our design into actual gates like AND gates, OR gates, flip flops, those kind of. That's what logic synthesis does. So we just provide the RTL design as an input to tools. There are industry standard tools to do the synthesis of RTL. So what those tools would do is they would take the RTL code as an input, and then they would just map the code into actual logic gates. They would convert the code into actual AND gates, OR gates, so that would be the next step. And then once that is done, we would again run simulations using that gate level netlist. That's what we call it. So the output of that tool would be a gate level netlist. So it would convert the RTL code into a gate level netlist. And so again, we would run simulations using that netlist to verify that we meet all the requirements as per the spec. So once that is verified, we then go on to do the layout. We call it the automatic place and route. So again, there are industry standard tools that assist in doing this layout. A lot of it is just automatic. We need to provide commands to the tool, and it would map the logic gates into actual transistor level circuits. So we started off with a very high level hardware description language, and then we used a tool to convert it to a lower level. We converted it to gates, and then finally we do the layout that converts those gates into actual transistors, physical transistors that would be inside the silicon. And so there's a bunch of layout verification steps that we need to make sure we do. We'll have to do timing analysis to make sure that we we meet the specifications. Timing analysis is basically so let's say that your CPU specification is that it runs at 3 gigahertz speed. So we need to verify that the actual silicon can meet all those requirements at 3 gigahertz. So that's what timing analysis is. I don't want to go too deep into detail about that to get confusing. So once that is done, we just release the layout to the fabrication facility, and they would fabricate into silicon, and they would package it, and this would be the end product. So we went from a hardware description to gate level to transistor level, and then that is what finally gets fabricated. So inside this, you'd see millions or even billions of transistors. So a typical CPU would have billions of transistors. So some of the basic course knowledge that you would require to do this kind of work. The basics is digital electronics. I'm sure you guys have taken those courses that I've listed here. Digital electronics, VLSI design, basic analog circuit design, DSP, data structures. Now you may think that being a hardware designer, you don't do a lot of coding related work, but what ends up happening is you do the RTL coding, but the verification requires a lot of C, C++ coding methodology that we follow. So so you have your design. Now to verify your design, you need to provide input stimulus to check that your design works correctly. So to generate those input stimulus, we do a lot of C, C++ coding to generate that kind of stimulus. So let's say that you have some memory module that you want to verify. In the actual system, the memory module is controlled by the CPU. Now the CPU, when you run simulations to just check the memory module, you're not going to actually use the CPU in your verification system. So we just write C code that kind of mimics the CPU behavior at a very abstract level, and then that's the input that we drive to the memory modules, and then verify the behavior of a memory. And then so these are some of the tools and languages that I use on a daily basis. So for RTL description, we just use the text editor to write the RTL code. So Verilog and system Verilog is what we follow. And then C, C++, like I said, we use that for generating input stimulus to do the verification. And then we do quite a lot of Perl scripting. So we do that to automate some of the processes that we follow. Let's say that when we run, so when we are doing the verification, we run simulations, and the simulation would give us a log file. If there are any errors or warnings, we'll have to look at the log file to identify what those errors and warnings are. So to do that, we just write a little Perl script that goes through the log file and just separates the errors and warnings from the log file, because the log file could have like uh, hundreds of thousands of lines in it, when we do the verification. So it would be very difficult to go line by line and figure out what the errors are. So we just write a Perl script, that parses through the file and then picks out the errors and warnings. So for simulation, we use Cadence, simulation tools, Excellium, and SimVision is what we use to actually view the waveforms from this of the simulation. And then logic synthesis, we use a synopsis tool called Design Compiler. So that's what gets used at this stage when we convert the RTL code into a gate level netlist. And then for the actual layout, the place and route, we use Cadence Encounter. And in the system, we mostly work on a Linux-based system. So some basic knowledge Linux commands, basic knowledge of Linux commands would be very useful to add on your resume. So I briefly described the process at a very high level. Let me see if I can just show you a little example of of a system. So let's say that can you see my screen?
Yes, we can see your screen.
Okay. So let's say that the requirement is to design an adder. Okay. So adders and multipliers are a very important part of the CPU. They go into the ALU part, the arithmetic and logic unit of the CPU. So
Subhash, we can see only our browser.
Yeah, your Chrome screen. We can't see the other screen that you're typing in.
Oh, okay. Let me see.
I think you should put the button. The option where you say share the whole desktop rather than the share the screen.
You need to share the other screen, Subhash. You can. You will have to say share another screen.
Got it.
Yes, got it. Yeah.
Okay. Okay. So let's say that you get a requirement in your specification to design an adder. Let's just make it simple. The 4-bit adder is what you're going to design. So what I would do is, the code would look something like this. It'd be called module adder, and okay, so see. Okay, I'm not able to type in. Okay. Okay, for some reason, I'm not able to. Okay, let me go back to this. Can you see the screen now?
Yeah, we can see your Chrome screen.
Okay, so for some reason I was not able to, I don't know what was going on, but the notepad was behaving.
That's okay, Subhash. That's
so,
okay.
Yeah, so basically what I was trying to do was do a design an adder. I was planning to show you, what goes into the code, but some problem with the editor. So yeah, so once we get the specification, we would just code up the module using Verilog, system Verilog, and run simulations to verify it, and then go ahead with the rest of the process. So that's basically it. That's all that I had planned to show. I can move it over to Sheila now.
Hi, so we saw previously like how an Asic design has been done, and even Sakthivel told about like how it is used, how in a system level it is used, and how they do the schematics and the PCB layout. So once everything is done, you get the hardware, but you just have an hardware, but how does the hardware know what to do? So in order to make the communicate with the hardware, we need to write software. So that's basically my role. So I'm an embedded software engineer, and it's not just one software. So we have like multiple softwares has to be written because ICs and hardware. But how do we communicate with the IC? So for that, we need device drivers. So device drivers are the drivers that would communicate with the IC on software level. And then bootloader. So what is a bootloader? So bootloader is a software program that would run in the initial stage as soon as you power on a system, and that would help you to initialize all the programs that are required. And then our real-time operating systems. So real-time operating systems is like the name says itself, like it's operating systems in real time. Say we have considered of example like mobile phone. We all know iPhone has iOS, so that is an operating system, and we need to write do software coding to make the to build an OS, that's an operating system. And apart from that, the top layer one is the application software. So what application software does is like we take the information from device drivers, real-time operating systems, and they're like other architectures too, and communicate with the built-up system to perform what we need to do. The application software is basically like it would give the commands for the system to work like how we need it. So this is very much a generic diagram. And basically what an embedded software engineer does is like write software for the hardware. So we need to, apart from coding knowledge, we should have even knowledge on the electrical components and the electrical systems. So I would like to share like what are the important course knowledge we have. Yeah, we need to know DSP. So deep knowledge on DSP is required, and then digital electronics, because we need to understand how the ICs work, basic ones and zeros gates to write the code or algorithms, and then communication protocols. So let's take any embedded system. It requires to communicate with one IC to other. So we need to know basic communication protocols. So I think an undergrad you would have studied about TCP/IP, UDP, the basic packets, how it travel. So about that. And apart from that, I had taken like few courses in my master's, which I've just mentioned here, like design with embedded systems. So that gave more knowledge on what embedded systems are, how it works. And real-time operating systems is also a very important subject to write the code. And then data structures and algorithms. So that's like a very basic course, but we need to understand it very clearly to write the software. And I would like to even mention the day-to-day tools and languages we use. So embedded C and C++ is like to write the application software, and MATLAB is also used extensively. That is mainly for if I need to say, let's say in DSP, I need to design a filter. So how do I know the coefficients in the filter? So I would write a MATLAB code, and MATLAB would generate the coefficients. Not necessarily like we need to do the math and solve on paper. So MATLAB gives solutions for complex things. And then Python, you might wonder why Python is required. So Python is required extensively to write test scripts on when we write a code, but how do we test it? So to test it, we use Python scripting. And apart from that, we can even build automation testing frameworks in Python. So you build everything, you click a button, it's going to test all the requirements. So that is one thing. And Linux. So certain systems might require Linux, so will work on Linux basis. So for those systems, we would require Linux. And if anybody is like interested, like to know more about this, there are like a lot of things like most of them would have heard about Arduino boards. So that is an embedded system, and we have a lot of things in online, like embed compiler. So it's an online compiler where you can write the code and compile and see. So those are the things that would be helpful if anybody wants to get into this field. Yeah, that's it from me. Oh yeah, and I just wanted to brief like what are the different types of engineers that work. Uh, so now we showed like how a product is developed. So the first thing is a research engineer. So research engineers would research on the product. That's mostly basically more on R&D, and they need to have a very strong knowledge and experience for that. And then algorithm development engineers, so they bring in a logic and try to show that this would be a feasible one. And then IC architects, so they would give the specifications how an IC has, what should be there in an IC and how it has to function. Then ASIC designers would design based on that, and product engineers would yeah, so the product engineers would do a lot of testing for different scenarios, and systems engineer would build the system completely by doing the schematics, PCB layout, and software engineer would write the software for all this hardware. And application engineer, you might be wondering who an application engineer is, but an application engineer is a person who would so we have a mobile phone. So mobile phone has a very good user interface. We just go to the shop, we buy it, we use it. But if you take let's take, I work in the automotive industry, and the systems which we build is not something like which anybody could handle it. It has a lot of complexity, and it doesn't have a great user interface like anybody could use it. So on such, for such devices or tools or anything, there is a person called application engineer who would explain to the customer and help them to use the particular device. So and even those people should have a good knowledge on how the system works. That's where they hire engineers, and that's what an application engineer's role would be. Yeah, so that's it from me.
Okay, yeah, thank you, sirs and ma'am. So yeah, so we'll move on to the general questions, if you don't mind. So hopefully the participants can hear the questions. So I have a couple of questions from my side because I'm currently pursuing my final year in engineering. So in this current moment, in this era of COVID-19 and the new normal, so some of the questions that I asked you was, what do you think is a good path forward? Should I complete my master's degree, or should I get up a job quickly? This is open to both, all three of you. Anyone can answer. So the question is, should I go start my higher studies right now immediately, or should I wait and work for a while and then start my higher studies?
Actually,
let me take a shot at it. So with the current situation, is if I were in your position, you know, there's a lot of things going on. You know, the situation is fluid, and it's every week things are changing. So I would right now hold off, you know, trying to apply to universities and go with doing my master's. I'll just wait for 1 or 2 years for things to settle down, because right now I think even if you get an admit, a lot of universities might only offer online coursework. So I personally, I don't know if it's, you know, worth it to pay 20-25 lakhs to do online study, you know, because a lot of the experience here comes from, you know, actually interacting with you know, different students and working in the labs. So with, you know, with things a little unstable right now, I would hold off, wait for a year or two, and then you know, think about it at that time. So right now, my opinion is just go ahead and you know, look for jobs, and then, you know, take up a job right now.
Okay. Is there any other opinion, or?
Yeah, I would like to add some points.
Yes, sir.
So so regardless of the current situation, always it should be like, why do you want to do masters? That's the first question that should arise within you. So it should be like that you are interested in a particular field and then you want to explore more. So if that's the reason you want to do masters, then just fine. But just because you're not getting any jobs, or just because your friend is doing that, then it's not a good decision really. So what I would say is you have to explore what you are interested in. For example, which field or which subjects are you interested in? It might be embedded or system design, electronics design, or even communications. So you have to explore and research over the internet, and then gain some knowledge about the subject. So if you want to do a master's degree, that's fine, but you should be in a position to choose the courses correctly. Choose the course that you're interested in, and also once you've decided that, you have to choose the university which is good at that course, which offers the best of that course, and then that's the way forward. So the first step would be is to find the field that you are interested in, to find subjects that you're interested in, and then explore more. There are a lot of online courses available. I mean, if you had missed, or if you didn't understand your bachelor's courses, that's fine. You can always refer to online courses, and also there are a lot of materials available in YouTube in this time. So explore the subjects more, explore your interests first. And also, as Sheila said, there are also options of doing it yourself, like buying an Arduino board, programming it, and also there are software-defined radios if you're interested in communication systems and stuffs. So you can buy an SDR in Amazon and and try to program it. There are open source communities like GNU Radio that offers a good DSP libraries that you can play with the software-defined radio. So you should really explore these stuffs, and then make a good decision of your career, whether you want to work, or if you want to do a master's. So first you should explore your interests.
Okay, yeah. Thank you, sir. So the next question is, so basically, so this is another dilemma that the engineering students are having right now. So should we stay in India? So because since there is a lot of speculations about new normalcy and the COVID crisis, a lot of people are questioning whether they should move out of India, go to either the United States or Europe. Talk about making the job market in India grow in the electronics and communications field especially. So what is your thoughts on it? Should we stay in India? Should we look for jobs abroad? Is it better to stay in India for a couple of years and then again move?
So
it's open to everyone actually, so anyone can answer.
Yeah, okay. I think first I will answer, and then maybe others can. So India right now has a good number of job positions. I mean, so with the majority of the job market or the job roles available in India is mostly linked to testing, and I mean, as far the core industry is concerned, there are most number of jobs available are in the testing profile. So if you are okay with that, then it's fine. Again, you have to explore your field, and then do some research about the job profile, whether that's a thing that you like or not, and then go forward. So and then after that, there are little I mean medium to little number of jobs available in the design and development sector. So for example, in the company that I have worked, the data patterns, they do in-house design and development of electronic systems. So there are also a lot of companies like that in Bangalore and also in Chennai. and yeah, and also going forward in the research and development, there are only a little opportunities available. So it highly depends on what kind of job you're looking for. If you are really interested in research and development, and you really want to pursue the career, then yes, doing a master's in in US or any reputed universities abroad would be a better option than staying in India. Or if you're okay with the design jobs or the testing jobs in India, then there is no problem in staying in India.
Do you guys have any thoughts?
Yeah, so like you said, most of the profiles that I've seen are related to testing. I've seen a few design related jobs in Bangalore. There are these companies, Intel, Qualcomm, Nvidia. So those do have design related positions open. But if you look at the job requirements, they talk about requiring experience in verification methodologies, proficiency in Verilog, system Verilog. So that kind of stuff, I don't know if we get a lot of exposures during our undergraduate studies. So even if you get an interview call, to be able to clear those, you need to acquire those skills. It doesn't necessarily mean that you need to go pursue a master's degree. To get those skills, I think there are quite a few training institutes that offer you those trainings. I know there are a few institutes in Bangalore that do UVM verification methodology training. So that's universally used right now in the industry. So those training institutes are there. So it doesn't necessarily mean that you need to go do your master's. And also in terms of job stability right now, the work that we do, designing these products, electronic products, they don't go to the market like tomorrow. We're not going to go sell it to the market tomorrow. So what we are working on right now is future revenue for the company. So what happens right now in the market doesn't really affect the work that we do. So we are developing products that are going to be used 3 or 4 years from now. So in terms of job stability right now, it shouldn't affect core jobs a whole lot. I mean, there could be instances where a company's business could be hurt during this time, but vast majority of core companies should be able to survive through, because the products that we work on are going to be used like 4 years from now. So that's kind of my take on it.
Okay. Ma'am, do you have any thoughts? Or?
So like, yeah, in India, even my company, I work with few people in India. They are in Bangalore. So we actually design and develop the code, and what they do is like testing the code. So even they use the same embedded system they would have what we are using. They would also work on the same tools. They should also know the same protocols what we are using for communication protocols or whatever. But what they do is like just testing, but they don't develop the code. But I would say testing is also not an easy thing, because you just can't test something without knowing what the product is or what the software is, what the architecture is. We should even have a great knowledge on testing. And apart from that, we should even think a lot, testing something in the same monotonous way, it's going to result, yes, it is fast. But when you give a different scenario, how it reacts, that is what is more about testing. And even to do for different scenarios, we need to think, and that also comes with experience.
Okay,
Yeah.
thank you, ma'am.
Yeah, and also don't get us wrong that India has only testing profiles. India also, as Subhash said, companies like Qualcomm or Nokia in Bangalore and all, they have good design and R&D positions, but they take students straight from IITs, and also they also take master students from IITs. So So you can also take a GATE exam and do a master's in IIT, and then try to get into those companies in India.
And as Subhash said, you can also take like that really good courses that would specialize on that. So you would have, see, basically, how would you end up getting a job? You, if there are 1,000 people, how would you excel from others? That is how you would end up getting a job. So you have to see what skill we have to develop, what skill set is there for the job. Then we would end up getting the job.
Okay, yeah, got it. So from what
Yeah, and also, if you know of people who work in those companies, try to network with them.
Okay.
Because getting an interview call is the most difficult part.
Understood. Yes.
Once you get an interview call, then it doesn't matter, how much, what your GPA is, or what you've studied. It doesn't really matter. All you need to do is,
have deep
crack the interview. Because the interviewer, they don't care about what you've studied. All they want is, if you have the basic knowledge. So even in your interviews, they're not going to ask you like complicated questions. It's going to be very basic, fundamental stuff. And then all they are looking for is if they would be able to train you, if you have that, curiosity to learn and, pick up things quickly. So that's what they're looking for, in a job applicant.
Okay, thank you. So, okay, some more, man.
Yeah, all you need to do is like you have to be very strong with fundamentals. Even after masters, I went for interviews. So when I'm trying for internships and full time, they asked about lot about the analog circuits, ECE 1 and 2, digital electronics, what we do. So that is what they asked basically.
Okay.
More deep on that.
Yep. Have your Vesti and Harris book always on you.
Yeah, sure.
Book.
So,
EDC is the most important.
Yep. I still have my Vesti and Harris book. So when during my undergrad, I don't think I really followed that book. I think I used some local.
That's a problem that all of the students have. We tend to go with the local authors rather than the foreign authors, because local authors are they simplify things.
Right now, I go look at stuff on that book regularly.
Yeah,
I actually use that book.
I think that should be put more strongly, Subhash, telling all our students, please follow all foreign author and prescribed books.
Yeah.
Right.
And to add on, this Arduino programming right now we are giving in our college under EFI banner, Electronics for You. And one more is this Qualcomm. They have taken our students' resume this time, and we are awaiting. Yeah. We are awaiting.
Few of our students. I'm not sure. Yeah, I think.
Yeah, few of our students.
Yes. Actually, that was a hackathon going on with Qualcomm. So some of the CSE and ECE students, I think they got an offer to go. I'm not particularly sure about it, but yeah. But I understand about the Indian market job specifically. So let's move on to the student questions of the Q&A. So there are a lot of questions from which you already answered. So one of the main ones that I also already wanted to ask was the scope of data science and artificial intelligence. So do you think it plays a major role? And because since a lot of EC students themselves are learning about the basics of machine learning and data science in the core, so do you think they have a scope right now? Is it viable to study that particularly as a specific field, data science and machine learning?
Yeah. Absolutely. Because right now, I see a lot of companies migrating towards, cloud computing and AI related stuff. So even so I can talk for myself. So for Asic designers, there are all these companies that are hiring Asic designers because, if you take Amazon or Microsoft, they have, cloud computing products where they store a lot of stuff on their servers. Now, the servers need computing power, and that comes from, processors. So all those companies right now are hiring, Asic design engineers and stuff. So what I'm trying to explain is, yes, data is going to be a big part moving forward, and data science and artificial intelligence. Even where I work, there are people who are doing research on coming up with algorithms for AI. that could, process things faster. So there's a lot of applications for AI in the future. So
yeah. So everything is going to mostly based on AI in future. So even I work on automotive industry. So even in my company, we have like a particular team, just like that would be like for autonomous cars. So autonomous cars would work only based on AI. It should be able to detect if a person is crossing, what the traffic light is. We have a lot of prototypes currently, but to do it on like real-time scenario, imagine a car moving on its own on the road. There are like a lot of data has to be processed, and it has to be processed in this time.
Yes.
So even our radars has to detect the data in microseconds and give the feedback. So everything, all these things, again, there it comes like data science, data engineering is also there, and then like AI. So everything is would be dependent on AI in future. Maybe even for future jobs, even we need to study AI courses to update ourselves. Definitely, I think that I would see that in future.
Okay. Mr. Sakthivel, do you have anything to add?
Of course, data science and machine learning is going to be the future. There is a lot of data available right now in the internet due to the internet revolution, the 4G revolution in India, and everywhere else. Everyone is using internet and pushing data to the clouds. So yeah, data science and analyzing that huge data and studying those data would be a crucial part in the future. So yeah, data science, jobs in data sciences and machine learning is going to be in the rise in the future.
Okay, thank you, sir.
Yeah, Sanjana is on the call. If you want to add something, Sanjana.
Oh, okay. Hello.
I don't think she's
okay. Maybe she's not on the call. That's fine.
You can ask like next week or sometime.
Next week she's going to be presenting stuff.
No, actually she has raised hand. We'll see. You keep continuing. I'll just let her in.
Yeah, so yeah, as to the students and the third year and fourth year students watching, so we need to basically learn more about data science, because a lot of companies right now expect data science to be one of the core skills that we have, at least basic skills that we have, so that we can actually move on to that or migrate to that. Okay, the next question is basically what we already asked. So basically, it says immediately higher studies, or you should do work and then postgraduate, and you already answered that, so we'll leave that out. The next one is from Thomas, sir. He's asking, what are the skill sets needed for VLSI verification engineer?
So VLSI verification is a very important aspect. So even though my job profile is an Asic design engineer, I spend most of my time, verifying the designs. So if there's a bug in hardware, it's going to cost you a whole lot to replace it, because once you design something, you send it out for fabrication, and it comes back, and there's a bug in your IC, you cannot replace it in 1 or 2 days. You have to redesign it. It has to go through the entire fabrication process, and then it'll come back. So that'll take you 6 months. So the cost that goes into these bugs are huge. So we spend a lot of time doing verification, and some of the skills that companies would look for in verification engineers right now is system Verilog and UVM. UVM stands for Universal Verification Methodology. So the test benches that we develop to verify our designs are mostly class based. So when I say class, it's C++, object-oriented programming. So we have those classes defined as in our test benches, and so that's the methodology that we follow. So everybody for any verification engineer role, they would ask for system Verilog, UVM, C++. Those 4 things are very important, and they'll also ask for some knowledge of some scripting language like Perl or Python. And then of course you'll need to also understand some of the basic design stuff like synchronizers, filters, those kind of basic stuff. Um, yeah, so that's what a company would typically look for in a verification engineer. System Verilog and UVM, those are the most important. Yeah, I mean, if you can, if you can go to YouTube, there are a ton of videos that offer you basic System Verilog and System Verilog training. For UVM, it's relatively new. I think it came up in 2015 or something. So I don't know if there are a lot of training modules on that, but I'm sure there are some materials online that provide you with training.
Mr. Sakthivel, ma'am, do you have anything to add, or can we move on?
Yeah, we can move on.
Yeah, okay, yeah. So I think there's a professor, assistant professor asking a question that he's pursuing his PhD right now. He's asking any courses that he needs to do that he can move on to the core field. So we have a lot of staff also joining us as participants. So they also want to move into the core field, either in Europe or America or even in India. So what are the courses that you would suggest that would help him move on to the core field?
What is the major he's doing in PhD?
Right.
That's the first thing.
I didn't think he specified that.
Okay, so like in undergrad, basically you would do touch courses on all the electronics and communication. When you go to master's, he did electrical and I did computer. So the major will differ. Where you major will differ. So they would do major even in communication, like what Sakthivel did. So based on that is what the courses can be.
So okay, if he's pursuing PhD right now and then wants to move to industry, I guess, because core field, in the sense he is already in the core field in my sense, since he is doing PhD. So but the question is, if he wants to move to industry, then I think he could, but it's going to be difficult because he has to see how he can bring the skills, same set of skills, same as a person who has already been in the industry for years. So he has to compete with such guys.
Yeah, but I think he was asking what skill sets that he needs to learn right now immediately.
Yeah, that depends on the field. So okay. For example, I will tell for communication systems. So skills like MATLAB or product development, software development, lifecycle. So and also depends on companies. If he wants to move to a company that develops algorithms for 5G or LTE communications, then skills like since he's doing PhD, I think he would be good in the subjects. So the other skills that would be the tool skills. So in this sense, C, C++ would be good to have, and also MATLAB. So yeah, C and C++ are the major skills, because we develop and test the algorithms in C++ before moving into hardware. And also right now, the entire mobile communication is moving towards software-defined radios. So even now I'm working on SD-RAN for 5G. So the thing is, till now, the mobile operators used proprietary hardwares to build their base stations. So and then from now on, the base stations will be running on servers, cloud-based servers. So yeah, basically the RAN and the RAN part, the channel encoder, example, the channel encoder, the FFTs, IFFTs, the OFDMs, everything is going to be in software in the future. So yeah, skills in C and C++ are definitely important.
Yeah, I think there's one more question there, and I think it's specifically to ma'am. What do you think is essential in embedded systems, deep learning, machine learning? So how do you think we should learn that specific deep learning or machine learning, and is it very essential to embedded systems in the future?
Yes, definitely. So it's like I never worked on deep learning or machine learning, but while I did my master's, there were like a lot of my friends who did thesis on neural networks on embedded systems. They had to code for a network, and then they had to deploy it on a hardware that's an embedded system. So basically, first we need to be really strong in coding. So C++, once again, and data structures. So
Yes.
it's like, see, when we do it, and when I did my undergrad in college, so I'm not a very good person who can code everything. So what I after started doing my master's, so what you can do is like how to improve it. There are a lot of online C compilers, see, even W3 schools and Geek
Yes.
for Geek, all these places you have the online C compiler. So they would give an example for the C code. First put it, compile it, and see what the output is. Then you try to change something in that,
Yeah.
and then see what the output is. That's how we can learn coding. We cannot learn coding like in overnight.
Yeah.
So keep develop, like keep trying, and then like you will start understanding how things are flowing inside the code. So
Yeah.
that's how you can develop coding. So this coding part will be very important, because neural net AI or machine learning, it's mostly about coding, because they'll have, I think, different networks. They have something like squeeze net. I think that's one structure which I
Yes.
need.
I think a lot
Like,
of algorithms is still changing. So
yeah.
different
So how
algorithms.
do you do that? You need to code. So we need to learn the coding basics strong, and then like apart from that, it's not we do a software code, it's fine, but how will that communicate with the hardware? So you have to know even hardware a bit. If I'm using a processor, so we should know how what the processor power would be. How I should be able to handle the hardware using my software. Because if you have a hardware like this, an IC, it's not going to do anything. Only if we do give the right software commands, it is going to work. So a good knowledge on embedded systems. We have a lot of, see, if you want to, if somebody is interested, you have a lot of options in YouTube now. Apart from that, I think you have courses like Coursera and Udemy. I think they
Yeah.
even give certification. And
Yes,
for
ma'am.
students, if you write an email like you're a student, you're not funded, and all those things.
Actually, the college, KSG College has actually given us a free course during this pandemic. They've actually given a bunch of free courses which are actually expensive. They said due to the pandemic, you can have the free courses. So we actually a lot of
Yeah. So
courses and courses are free. Yeah.
you can add these courses in your resume. So that's how you build up your resume.
Okay. Thank
Yeah,
you.
these would be useful.
And so for coding, the basics are is what's very important. So
Yeah.
if you're good with the basics, then you can always expand. And learning new
Language.
methodologies is not going to be difficult. It's just going to build off of the basics.
Yeah.
So
If you know C++, you can do even Python classes methods well.
Yeah.
So all the new scripts, languages which are coming, base is the same concept. So if you're good with that, it should be good.
So it's almost going to end. So I think last question from myself. So it was actually to Mr. Sakthivel. So a lot of my friends, especially, they're trying to move to Europe. They're trying to apply for universities in Germany and Belgium and some in France, I'm assuming. So one of the questions that propped up was, should I learn the regional languages? For example, in Germany, you're supposed to have a basic level of German, I think A1 or A2 level. Is it the same to all the European countries, sir?
Actually, some universities have this mandatory requirement that that you should hold A2 or B1, such like that. But if there is no restriction, it's all up to you. Then I think basic German to survive would be good to have.
Yes.
And also it depends on the industry that you are going to. For example, if you are into electronics or mechanical or automotive industry in Germany, a lot of the companies are German based. So so German language will be used in the office and also through the work. So German language is crucial in that case. But if you are into communications or computer science in those fields, then I don't think German would be a crucial requirement.
Okay, I think that's it. There are no questions. Ma'am, Kavita, ma'am, do you have anything to ask, ma'am?
No, that's it, Jonadab. I think all your queries, it was answered, and
Yes, ma'am.
very happy to hear from all my alumni. And I think they've given good insight about their experiences. Hope all my students would have got benefited. And thank you so much on this Saturday evening. You all have spent some time with us. So keep in touch with us, Subhash, Sheila, and Sakthivel.
Yeah, okay, ma'am. And also, if any of your students wants to ask more questions, they can write to us an email, and then I would like to.
I was about to ask that. Can you just display your
Share
email
your email. Yeah,
email
share your
ID.
email ID.
Either the public chat or you can just post it on the screen.
Yeah, just
Because just another reminder, because a lot of the final year students are actually trying to apply to either jobs or higher studies in the United States or Europe. So they have a lot of questions because a lot of them are not. I'm sorry, they don't know the proper steps to take to go into those. So I think that a lot of people will be glad that they have some kind of mentor to look forward to.
Yeah, actually we were thinking like if anybody wants like a mock interview. So you said like people have got into you have submitted the resumes to Qualcomm, and if suppose
yes, Sheila, that was said by Sanjana. Actually, I'll let you know. I'll arrange for that, and I'll let you know, Sheila. And thank you all for doing all this. I'll let you know in a short while about this.
Sure, but actually like that would be like really helpful for them. And
yeah, it will be really helpful for them. That also this moment they are all a bit free, I know, so they can participate in all this mock interviews and all that. I'll let you know in a short while. I'll get in touch with you people.
So to all my students who are watching, so they just sent their email IDs in the public chat. You can go watch, check the email ID. So if you have any questions, please address them. Just put a subject saying that inquiry about career opportunities / experiences, and you can just ask them. And ma'am, so we'll end it with a word of thanks, ma'am.
Yes, Jonathan, go ahead.
So basically, thank you, sirs and ma'am, for coming here. So it's been a pleasure. As a student myself, facing like uncertain future, it's been really helpful because a lot of the questions that we had is basically the common question that all the students have. So it's very helpful, very insightful, and at least it clears our path a little more. So thank you for that. To summarize, to summarize the whole webinar, so it is basically regarding the core industry in electronics and communication, and how each of the alumni experience their jobs, and they explain each of their roles. And at the end, there were a lot of questions about whether to do undergraduate or postgraduate, as in like job immediately after undergraduate, or do to a postgraduate. And so a lot of insights about how it's better to have a job, and then you move on to you find your rhythm, or you find your specific field, you research on that, and then move on to it. And then we are discussed about, of course, machine learning and data science, and that is instrumental because a lot of young kids, as in like engineers who are just learning about coding, they want to move into data science immediately. So that was also very good. And I would like to especially thank Kavita ma'am for giving me the opportunity to moderate it. And I thank Mr. Sakthivel all the way from France. He's working from Eurecom for attending this. I thank Mr. Subhash and Ms. Sheila for all the way coming from United States. Thank you very much, ma'am. And I thank Pawan sir and the KCG College administration management for actually conducting this review and giving us the Zoom meeting. So thank you very much. And thank you for the students and all the staff and other people visiting here. Thank you very much. Hope you had an informative and very challenging or a very productive webinar. Any final words, sirs and ma'am?
Thanks for taking the time to attend the webinar, I guess. And if you guys have any questions, feel free to send us an email. We'll respond back as soon as possible.
Sir, anything?
Yeah, thank you for the webinar. Thank you for having me. And I have one more last tip, which is about the final year project. So I want to say that do the project on your own, and don't go for project centers, because that's a big mistake that I did, and I regret it till today. So actually,
Sakthivel, now I just put a point here. Now, like we've made it a mandate. People should do their projects here in college, and we are doing so much of mentoring. Even Jonadab, he went to a foreign country to present his project.
About that, actually, you have to give a lot of credit to the management itself. So a lot of, in KCG itself, a lot of students, not only from EC department, but EC department, we already actually been to Sri Lanka, Thailand. We're planning to go to Malaysia, I think, next year. Aero department, they went to Russia, China, they went to United States. So a lot of opportunities are coming our way. So a lot of research work is going on, and even in EC and especially the CS and the aero field. So
because these kind of final year projects and all are very crucial when you attend the interviews during the core industries, so that's very important. If you do it through project centers, then you won't learn anything. So that's a small point that I want to make.
Thank you, sir. Thank you, ma'am. Ma'am, any more last words, and can we end it? That's the question.
We can end it, Jonathan. Thank you all, and be in touch.
Okay, ma'am.
Thank you. Thank you.
Bye.
Don't forget to fill the feedback form for all the participants, just to get your certificate. Just fill your feedback form to get the certificates. There's a link in the outset, so you can get fill your feedback form, and then you can get your certificates also. Thank you.
All right. Thanks, guys. Bye.
Bye.